Lesson 5 of Chapter 5 is on product to sum identities. You can see they're listed up above. We've got one that goes sine times sine. You can change into a cosine minus cosine. This one, if you've got a cosine times cosine, you can change it into a cosine plus cosine. The next one, you've got a sine times a cosine. You can change it into a sine plus sine. And then if you've got a cosine times sine, you can change it into a sine minus sine. These are called product to sum identities because you're changing a product of two trig functions into a sum or a difference. And let's just first use a couple of them to make sure we're understanding how the formulas work. Before I get into this first example, though, I want to tell you that today I was reading the newspaper at lunch, and I was reading about, aging, and certainly I can recognize the last few years that I've been aging. And the good thing for me is that the article said, old mathematicians never die. They just lose some of their functions. Good stuff, huh? Okay, so if you look at our expression, we've got the cosine of 5x, the sine of 3x. And we're going to use this identity on this problem. You're going to let 5x represent angle A, and you're going to let 3x represent angle B. If we do that, we can change the cosine of A sine of B into the expression 1/2 times the sine of A plus B, which in this case would be 8x, and then minus the sine of A minus B, which in this case would be a 2x. Last thing I'm going to do is just distribute the 1/2 and get the expression 1/2 sine of 8x minus 1/2 sine of 2x. Pretty simple formula to use. Here is another one. Let me first just eliminate this. So we've got the sine of 4 theta times the cosine of 1 theta. And to do this problem, I'm going to use this identity. And we're going to let 4 theta represent angle A and 1 theta represent angle B. So we're going to change this expression into 1/2 times the sine of A plus B, which in this case would be 5 theta, and then plus the sine of A minus B, which in this case would be 3 theta. Again, I'm going to take and distribute that 1/2, and that's going to give us the expression 1/2 times the sine of 5 theta plus the sine of 3 theta. Oops, I forgot my 1/2. Let's go back and fix that. I'm distributing. This would be my expression. Okay, the example on the right, we've got the sine of 7x times the sine of 6x, and so we're going to use this identity for that one. And I'm going to let 7x represent angle A and 6x represent angle B. And so doing so, I'm going to change this into a 1/2 times the cosine of A minus B, which in this case would just be a 1x, minus the cosine of A plus B, which in this case would be a 13x. Again, I'm going to take and distribute. So that'll give us the expression 1/2 cosine of x minus 1/2 cosine of 13x. So that is just using these product to sum identities. The next thing I want to go over is we also have sum to product identities. This particular one says that if you have a sine plus sine, you can change it into sine times cosine. This identity says if you've got a sine minus sine, you can change it into a cosine times sine. This one says if you've got a cosine plus cosine, you can change it into a cosine times cosine. And then the last one, if you've got a cosine minus cosine, you can change it into a sine times sine. So let's use that to find the exact value of this expression that we see in front of us. Now we're going to let the 5 pi over 12 represent angle A and the 1 pi over 12 represent angle B. And since we've got sine plus sine, we're going to use this formula on this problem. So let's rewrite this sum as a product. And that's going to become 2 times the sine of A plus B divided by 2. Now, A plus B is going to give us 6/12 pi, which is just 1/2 pi. And then if you divide that by 2, we're going to get pi over 4. Then we're going to have cosine of a minus b divided by 2 is going to give us 4/12 pi, which is just a third of a pi, divided by 2 gives us 1/6 pi. So now we can just use the unit circle, and we can change that sine of pi over 4 into root 2 over 2. We can change that cosine of pi over 6 into a root 3 over 2. And now I can simplify this by canceling those 2's, and our answer would be root 6 over 2. I'm going to use the calculator to confirm this by doing square root of 6 over 2. And then comparing that to the original expression, which is in radian measures. So I'm going to switch my mode to radians. And then I'm going to type in the sine of, I believe it's 5 pi over 12. And then that's plus the sine of just pi over 12. Let me just double check that. Looks good. So now if we hit enter, we should get the exact same decimal. This confirms that we've got the exact value. Here's another one. We've got a cosine minus cosine. So let's use this sum to product formula, and let's change this expression into -2 times the sine of, now we're going to take a plus b. Keep in mind this is my angle A and this is my angle B. So if I add those together, that gives me 8/12 pi, which is 2/3 pi, and 2/3 pi divided by 2 gives me 1/3 pi, times the sine of, now we're going to take a minus b, and that would give us 6/12 pi, which is 1/2 pi. But then you have to divide that by 2, and we get pi over 4. So substituting in from my unit circle, the sine of pi over 3 is equal to root 3 over 2. Sine of pi over 4 is equal to root 2 over 2. These 2's can cancel, and so that gives me the result of negative root 6 over 2. Almost the same answer that we had on the last problem. Now let's confirm our answer by typing in, actually it's the same thing as this, I believe, with a negative sign in front. So let me put that negative sign in front. Should get the same thing as the cosine of, I believe we've got 7/12. And then we are subtracting the cosine of, oops, let's get a minus sign in there. Cosine of pi over 12. And that gives us the same value, so that confirms that our answer is correct. Good way to check your work. Well, as you can imagine, we're going to finish by solving equations. So you can see that the example that I have in front of you shows that we're going to solve this equation. And we've got a cosine of 4x plus the cosine of 2x. I'm going to use this identity and change that left-hand side into a sum, from a sum into a product. So using this identity, I'm going to rewrite the left-hand side as 2 times the cosine of, let's see, a plus b divided by 2, given the fact that this is a and this is b, would give me 3x. And then we'd have the cosine of a minus b divided by 2, which would give us 1x. Well, now if I divide both sides by 2, I have the cosine of 3x times the cosine of x equals 0. And technically, these are both in a factored form. So I can set each factor equal to 0. So if I set cosine of x equal to 0, it gives us solutions of pi over 2 and 3 pi over 2. This one's a little bit harder to solve because of the 3. So if I set the cosine of 3x equal to 0, we're going to have 3x equal the angles where the cosine equals 0. Now I wrote the first 3, but there's many more, okay? And so now I have to take each of those and I have to divide by 3. So pi over 2 divided by 3 gives me pi over 6. Pi over 2. 5 pi over 6. Continuing on, the next one would be 7 pi over 6. The next one would be 9 pi over 6, which reduces into 3 pi over 2. Technically, I don't really need to write this twice. because I do have it here. Come on. Computer's freezing up. There we go, now it's unfrozen. I do have that answer here as well as having it right here. I don't need to write it twice, just like I've got this answer right here and I've also got it right here. I don't need to write them twice, but nevertheless, the last one would be 11 pi over 6, and that's where I'd stop because those are the answers between 0 and 2 pi. Now I want to show you a way to confirm your answer graphically. So if I take the original problem and if I go to my graphing calculator and if I type in the cosine of 4x plus the cosine of 2x, now when I graph this, I'm going to need to know what mode I'm in. I'm going to do this in degree mode. Actually, let's stay in radian mode. And then let's check out our window. My window, I'm going to go from negative pi divided by 2, which changes into a decimal. That's my minimum. My maximum, I'm going to go 2 pi, which also gets changed into a decimal. My increments are going to be pi divided by 2. I'm going to go down 2, I'm going to go up 2, I'm going to go increments of 1. And now if I graph this, you're going to see a pretty unique looking graph. And all of these x-intercepts are going to represent our answers. Now if we look at all of these answers that we have, specifically the first one's at pi over 6. So if I trace and if I type in pi divided by 6, it gives me our first x-intercept. The next one was pi divided by 2. The next one, I think, was 5 pi divided by 6. So you can see that each of these answers graphically are matching up with the answers that we found algebraically. It's a good way to check your work. Let's do one more example solving this equation. You can see that this particular equation, we're going to use the sine plus sine sum to product identity. So I'm going to change the left-hand side into 2 times the sine of, again, keeping in mind that this is A and this is B, I'm going to get 3x times the cosine of negative 2x. I'm going to be able to now divide both sides by 2. And of course, 0 divided by 2 is still just 0. I'm also going to change that cosine of negative 2x into just cosine of 2x. What allows me to do that is our odd-even identities. You've got this odd-even identity. And to confirm that on the calculator, you guys know that if I type in the cosine of negative 10 degrees, it's the same thing as typing in cosine of positive 10 degrees. It gives you the exact same result. So now I can set each of these equal to 0. So the sine of x is going to have, the sine of 3x is going to have to equal 0. And then the cosine of 2x is also going to have to equal 0. So the sine function equals 0 at the pi's. And now I'm going to have to divide each of those by 3 to get answers of 0, pi over 3, 2 pi over 3, pi, 4 pi over 3, and 5 pi over 3. And then in the same way, I'm going to have to figure out where cosine equals 0, and that's at the half pi's. Here's a few of them. And if I divide each of those by 2, I get pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. So lots of solutions here. Now again, if you want to check that answer graphically, we can go to the graphing calculator and we can type in the sine of x plus the sine of 5x. And we don't have to change our window. We're still in radian mode. And so now you can see, again, a pretty unique looking graph. And we've got lots of answers. And so if we start typing in some of these answers, first of all, we had 0. We had pi divided by 3. We had 2 pi divided by 3. We had pi. So you can see all those answers. We also have